Well, hello friends. Welcome back to Browser Hacking. Today we are going to take a look at Discord in the Serenity OS web browser because we use Discord as our main communication hub for the project, but Discord doesn't work at all in Serenity OS yet, and it's definitely not something we can just make work in one video, but it would be nice to just get started on seeing what it looks like and what kind of problems we're going to have to deal with, things like that. So I thought, why don't we just try to open up our server invite link and see what happens, and then, take it one step at a time, just try to improve the situation. Okay, well, a lot of white so far, not very impressive. And the CPU usage has basically stopped. So it seems like this is as far as we get at the moment. If we look at the DOM tree, we can see that we have one div in the body and just a whole bunch of script elements. So probably what happens here is that this div is supposed to be filled in by JavaScript, but we fail to execute the JavaScript, or something goes wrong with the JavaScript. So we don't actually populate the DOM, and then we end up seeing nothing. So extremely broken web page, which is actually good because now I can show you exactly how I would go about debugging a thing like this. So the first thing we're going to do is figure out if there are JavaScript exceptions being thrown, because it could be the case that it's the website is swallowing the exceptions, and they don't. Normally exceptions are supposed to show up here in the debug output if nobody is handling them, but it could be that the web page is just catching everything and then we don't see it. Also, all of these unrecognized CSS properties and things like that, I think I'm just going to actually quiet all of this debug output for now. We'll just comment these out because it's really, really spammy. Unable to parse value for CSS property. Yeah, because, don't really care about these things right this very moment. Style rule selectors invalid. Yeah, so let's see. And then there was some, maybe that's the bulk of it. Oh, and these guys right here. Computed style for. Yeah, these guys. All right. So let me see. Right, so I suspect that there's going to be JavaScript exceptions that are being swallowed. So let's just dump a debug statement. So debug line, and we'll add some color to make them easy to spot. Maybe something like this, a throw in bright red, and then maybe the type of exception that's being thrown here. So just the exception value to string, and then we can also dump out the message. If the exception value is an object, then we can dump something out here. So I don't know. That's going to be in the message field, I guess. So exception value as object, get names dot message to value to string without side effects, something like that. Yeah. Okay, so not the most robust code probably, but it should tell us at least what kind of exceptions are being thrown. And then let's also print out the backtrace for the exception. What do they call frames? Oh, there's just frame. we have the traceback. So we can dump out exactly where in terms of JavaScript source locations. So we have the function name, and we also have the file name and the line number. Probably that will be enough. Although I suppose we could also include the column number, because why not? Function name, frame, source range, start. Oh wait, the file name, yeah. Start line and frame source range start column. Okay, yeah, so let's see what comes out if we just dump these. So we normally don't do this because it would be extremely spammy if the libjs VM would always print out every exception, because exceptions are not uncommon, but I guess they usually get caught. So this is purely now for debugging, although maybe we could put this type of thing behind a flag so I don't have to write this out myself. Either way, let's see what comes out. All right, we have something right here. Throw. Local storage is not defined. All right, so there's something right away. We don't have an implementation of local storage, which is a web platform feature. So they do use that, or at least check for that. We don't have it. That definitely causes a problem. So much spam from the CSS parser. All right, what else is going on here? Throw. Type error. Not an object of type number. Okay. And we also have what I assume is going to be like a bunch of minified JavaScript. Multiple assets here. This is kind of a hassle when you're dealing with stuff like this, but what I like to do is I like to fetch these assets, and then we'll take a look at one. So they usually look like this, like completely unbearable, right? And you can make them a little bit more bearable by just running prettier on them. Yeah, and then they end up looking like this instead, right? So the names, of course, are still irritating, but at least it's indented in a readable way. And then what we're going to do with these is we're going to hijack the request and then redirect them to a local copy that we have re-indented. Hopefully that will make it a bit more debuggable. So let's see, that was 12C1. And then we also had this guy right here, ADAB. So let's also get that one. All right, so we had 12C1 and ADAB. Seems like those are the two main resources here. All right, so now we have our own local copies of them. So let's do a quick hack here in the, I don't know, script element maybe, where we try to load them. So where do we fire off the load request? Fetching a classic script, right? So we can just do a little hack here. So if URL is equal to this guy right here, this is very, very gnarly, but hopefully it will just work. Okay, and then we'll do the same thing for the 12C1 script. Basically just rerouting these to our local copies. All right. Let's see how that goes. And the thing about this that's nice is that then we'll get line and column numbers that we can actually browse in this thing. So we don't have to keep track of what's where in the minified version. So the check for local storage is like on the main page. But now you can see these guys, they actually refer to our local file copy here. So let's see what's going on line 4266 in 12c1. Okay. To precision, not an object of type number. So to precision, what is that, by the way? To precision, that is a number API in JavaScript. Sure. 4266. Is this a polyfill for to precision, perhaps? It does kind of look a little bit like, or if it's a wrapper or something. I'm not exactly sure what this is. But this is what we're complaining about here, at least. Not an object of type number. Sure. So is it this invocation here that we end up doing, and then paren 1 paren 2 precision does not work? I don't know. We're gonna have to. There's a fair amount of guesswork that goes into stuff like this, but let me build a local REPL here. So it's good to have a local Linux copy of flip.js, so I can just interact with the REPL without having to disturb the Serenity instance. Let's see what else going on. Search string is not a string, but a regular expression. It's not a string, but a regular expression. Okay, so that's an error. Wait, that's an error that we throw somewhere in our code. But a regular expression. Okay, so that's actually a thing that we can complain about in our string prototype functions. That's interesting. All right, so we'll have to take a look at that as well. So it seems like somebody is passing regular expressions to some string search API, and then we don't like getting regular expressions in those particular cases. Maybe we're supposed to, but it's also possible that these are just like sanity checks or feature checks or whatever, or they could be testing for specific browser bugs. It's there could be all kinds of things going on. So we kind of have to just go into this with as few assumptions as possible. So the first thing I wanted to just investigate if this actually trips some kind of error if I do this. Okay, and then what happens if you call that? Oh, right. So if I say A is 1 to precision, not an object of type number, if I just invoke that, right? Sure. And here they are calling A with an empty object. So if I do that, what happens if I use JavaScript core doesn't work so well on my machine? Apparently, let's use Node.js. So 1 to precision, sure. And then A calling that like that. Requires that this be a number, sure. Now what if you do that? That doesn't work. A call. What if you, oh, call is with the passing to this value, I guess. Okay. What happens if you call it that way? 4266. So we are definitely doing this invocation. So it could just be checking that this works as expected. I don't know why they would want to check for that, but who knows? We have a string here that we could actually Google for, and oh, could this be from TypeScript? Aha. ES6 number 2 precision. So this is probably minified TypeScript stuff. And what are we doing here? This is a check for IE7 presumably, and a check for V8 on Android 4.3. So yeah, so this is probably some kind of browser detection or engine detection code. So I'm going to go ahead and think that it's probably okay to ignore those. And then we can look at this search string thing. So that was in 12C1, line 1206. What's going on here? 1206. So it's trying to... Wait, what is it trying to do here? It's a try and then catch. So we're throwing in the try. So this throws. And what is T in this case? Well, it's the function argument, sure. Nice and dynamic. And E is this regular expression. So what are they calling us with? Well, let's just, I guess we can just mess around again with the REPL, see what this might be about. So if you have a string like this, and then you, let's imagine that it was a 0, right? And then this doesn't do anything. You can't just right. So this part here evaluates to this character. And what if T is match, which I guess is an API on string? Then it would match that, sure. And this would not match anything. Okay, and then it depends on what it gets called with. Okay, so again, I feel like we're looking at some kind of feature detection code, or some kind of polyfill type of stuff. So maybe let's just let that one go. Okay, here we are throwing 2. 12C1 1603. And once again, yeah, this looks like more gunk like this. Maybe we should look further down at stuff that's not in like 12C1, because I'm really getting the vibes here that this is just a whole bunch of early initialization engine detection stuff. Like index must be a positive integer. That feels like a typical uint array check. Yeah, look at this. It's just verifying that it throws if you try to initialize a uint32 array with -1. Okay. And this is some entirely other file here. This one we didn't see yet. Here's some API.js. We also didn't see that one yet. Wonder what this one looks like. Okay, well, we are going to do the same hack where we download it. And then we're gonna prettier. And then we're gonna also make sure that we get the local copy, sure. And we also had the other guy named 3EAB, so we're gonna do him as well. All right. So I have no idea, by the way, how far, if anywhere, we'll get today. I'm just going to show you how I approach this sort of problem when we have a immature browser engine, immature JavaScript engine, and immature bridge between the two, and then we want to try to load a web page and see how we can improve the situation. So I think I'm going to want to have a local prettified version of that because it seems like we're throwing a lot in there and I don't know why. I'm just going to scout ahead and see if we have any other files that are also throwing a lot. Just a whole bunch of throw. Okay, what's that? Oh, it's still throwing. Still throwing to this day. Okay, well, that's probably going to end up being interesting then, if it's still throwing and like that's what it's doing right now. All the more reason to actually get it working against the local prettified copy. Also, did I actually make the local prettified copy? I don't think I did. That's not what I wanted. Let's see. Another benefit of having these local copies is that, wait, hold on, that wasn't even finished prettifying yet. Another benefit of having local copies of these things is that we don't have to wait for Serenity to download 3.5 megabytes worth of Discord JavaScript every time, because apparently that takes 18 seconds. Where I'm sitting right now, that's actually really quite a long time. And of course now it becomes instant because it's a local file, so really helps with debugging. And we could probably have some sort of better mechanism to sort of inject local copies of things like this, but at the moment there is no such thing, so we're using a hack. And let me clear my console there before we load. All right. And blah, blah, blah. And I really would love to see some of those 3EAB failures. So we are failing in API.js. Now that does feel like an issue. Maybe that's the first real problem if I'm being optimistic. So let's take a look at what that is. API.js 1360. All right. Create radial gradient. A hint. So I feel like this reminds me of like reverse engineering Windows executables and stuff like that. But at least we have this little hint right here. Create radial gradient. That is an API somewhere in the web platform. I don't remember where. I think it's related to Canvas. We don't implement this API. So let's go and look it up. All right. So this creates a radial gradient using the size and coordinates of two circles. All right. And it returns a canvas gradient object. So I think, what if we were to actually implement this API, even just a stub version of it that just returns a dummy object. And then we can see if we are able to make progress. Both of these throws here in api.js are at the same location when trying to create a radial gradient. And then there's also some kind of XHR here, or XML HTTP request, scouting out for whatever this is. Yeah, not obvious what that is. Could be, yeah, I really don't know based on the URL. BMCV result, request ID. Who knows? Anyway. Ooh, that's a 15-second load. Some of these load times are ridiculous. Yeah, let's see. Let's throw ourselves at the very first thing we've identified as an actual issue. Create radial gradient. So that goes in canvas rendering context 2D. And they want a canvas gradient. Let me actually just going at the Specarino. Can we see it in the, I guess we don't need to actually. Canvas gradient, create radial gradient. And then it takes doubles, I assume. Yeah, this is the IDL description of the API. Let's just grab that thing. Okay, and canvas gradient is what? It's this little boy right here. Let's add the canvas gradient class to libweb. So libraries libweb. That goes in the HTML spec because that's where it belongs. It's usually we put things in the libweb. We have a whole bunch of subdirectories and it's one per spec. So like this is in the HTML spec. So canvas gradient goes there. It's kind of a way to separate all the different classes so that we know, like when you're looking at a class, you can see which spec it comes from just by seeing which directory it's in and also which namespace it's in. Canvas gradient. All right. And then we'll just paste that opaque object. Not exactly sure what that means in this case. I'm sure it means something. Okay, add color stop, whatever. Sure. And then let's also add it here. So, there's a big list of things. Because it's accessible from JavaScript, we have to add a JavaScript wrapper class for it. So that goes in HTML as well here. So HTML canvas gradient. And let's make sure we alphabetize these for the people who care about the alphabet. And I'm forgetting something. I have to put it here as well. All right. So I think we're good. And then we can move to CLine actually, because editing with Vim feels a bit too slow. So let's go here, canvas gradient. All right, starting with the copyright. Namespace web HTML. All right, canvas gradient. What was the API? Add color stop. Returns undefined. That's void in C++ terms. So add color stop, double offset, DOM string color, sure. String const color. And I guess, I'm not sure what they mean by opaque, but maybe what they mean is that like you can't really introspect a canvas gradient object. So it's just like a value that you get when you call create radial gradient or create linear gradient or create conic gradient. So I guess by opaque object, they mean that it has no real introspection API. this is the only API that it has. But still, internally, we'll want to keep track of what kind of gradient it is, I guess, or if we create some underlying platform object or whatever. I don't know. But this is not... Wait, what am I trying to do even? Let's just say linear, radial, conic. I don't know, just something. And this is going to be exposed to JavaScript. So I guess we need it to be ref counted. And it's actually also going to need to be bindings wrappable. Yes. And maybe even final. Man, I gotta go look up somebody else who does this. You inherit from bindings wrappable and then you set the wrapper type. Right. Okay, I'm starting to remember how to do this. Gradient wrapper. Okay. Then we have to go and add that to libweb forward.h. Here are all the forward declarations for wrappers. And I also have an ongoing refactoring where I get rid of wrapper classes in favor of merging C++ and JavaScript objects. But that refactoring is currently blocked on some work that Luke is doing. So I am just, just waiting for that to land. Anyway, that's not really relevant right now. We are just adding another wrapper. So let's see. I'm just going to go ahead and add a simple constructor here, I guess. What inputs did we have? So I guess we want to have some kind of a create radial variant in our case. Create radial, and then the inputs were x0, y0, r0, and then ones as well. Right, XY radius, sure. Yeah, I don't know if we're going to need the linear one and the conic one, but we can still, I mean, it doesn't hurt us to add them, so. Linear, just x0, y0, x1. And then conique, start angle, and xy. Okie dokes. Okay, then let's go and implement these finally. So I think we can definitely get away without having to actually draw any gradients. Like, we just want to make the DOM load, right? So that's really my goal here. If we can make more of the DOM load, that will be a huge first step. So totally don't care if we can't draw a gradient, you know. Not here to do anything about that. So this thing will just let's just drop it on the floor, or we can actually debug something out. Canvas, gradient, add, let's say something like this, color stop. Just to be friendly, we can print out what we were given. And you know what? I'm going to put the destructor out of line here. Okay. Finally, we build these guys. Okay, so for now, let's just do something like this. Adopt ref new canvas gradient type radial. Yeah. Conic. All right, and then we're going to have to void out all of these values. Otherwise, it's going to chew me out about not using them. So just a sec, and we'll do that. Oakley dokley. And now what did we need? We need to add it here. Yeah. So let's go ahead and add the full API. X, Y, and then it started with the start angle. Okay. And then we have to add these functions to Canvas rendering context 2D. So here, I'm just adding them to the IDL file. This is basically, we have an implementation of the web IDL language, and we turn these into C++ wrapper code or auto-generated C++ code that knows which of our implementation functions to invoke for each of these IDL APIs. So here, this is a C++ version of Canvas rendering context 2D. So we gotta put these puppies in here, and of course we're going to bump that copyright date with the heavy work that we're doing here today. Wait, this is that file. What am I doing? Canvas gradient is what I wanted. All right, these things I think they can look like that, and then we'll just make them call through, basically. Okay. Okay. Oh, I didn't make those static. Oopsie. So much boilerplate. Okay. Is that enough? I'm not sure. Let's try to build it. Essentially, what we've done now is just add a canvas gradient object we need to actually expose that on the window object as a constructor. Window object helper.h. This guy needs to know about canvas rendering context 2D constructor and prototype. No, canvas gradient constructor and prototype. This is something that we should find a way to generate this code, but at the moment you have to actually go here and enumerate all of the constructors that should be available on the window object or the global JavaScript object in web context. So a little bit of a This is pretty hackish. Like, obviously we should find a way to generate this so that I don't have to go here and edit the file whenever I add a new interface. And then what's falling apart now? Let's see. Let me grab a clean build log here. We are failing in... Oh, there's no member named create radial gradient. Oh, did I just copy paste that without adding the word gradient? Yes, I did. Gradient. All right, fine. Still trouble? Oh, yeah, because I have to add them here as well. Okay. Okay. So I don't see why we would need to actually implement gradients beyond what we've done now, since we're not going to try to render them anyway. What did I forget? Forgot to add a wrap function somewhere. Yeah, I have to put that somewhere, I guess. Wait, doesn't that get auto-generated for me? Canvas rendering context 2D Pro. Oh, yeah, right. Oh, shoot. Yeah, this is always an issue as well. Whenever you're adding a new type that can be returned by somebody from an IDL function. So here I'm adding the canvas gradient type and returning it from functions in IDL. Then I have to actually go and update the wrapper generator to make sure that it includes that new class that I just added. So that would go in the prototype implementation, which is a bit of a hassle, but this is also very hackish, by the way. Like, we just make everybody include all the different headers. This could definitely be trimmed down. Probably would help build times to do that, but it would be a bit of work to get it all right. And now, because I edited the code generator, I have to actually go and rebuild logom as well. Not just, I can't just rebuild Serenity because the generator is part of logom. So it's a bit of a hassle thing, or more like a thing to know about if you're editing the code generators for libweb, that since they run on the host machine, as part of the build process, you have to rebuild the build tools because you're effectively editing the build tools. One of those things that many people never get exposed to because they don't hack on the build tools themselves. So can we please get a build? All right. Wonder, like, now I'm really curious what's gonna come next, and there's like this anticipation almost that, like, oh, now we don't know what kind of problem is gonna come up. Could be anything. I feel like most likely it's just gonna be some other API that we're gonna eat crap on, so to say. Just from like scoping around here, assuming that we'll like call the next few things here. I don't really know. Shadow blur, if that's something. That's just like assigning a field. Yeah, I mean, we'll just have to see what it tries to do. Not the most readable file, but it is what it is. Let's hope that we don't have to debug whatever the heck this is. Good times. Frickin' minifiers. All right, so maybe I could make a bookmark for this, but it's not like I've been typing it very many times. So let's see if this just worked. It's totally possible that I messed it up. We'll see. We are now failing. Oh, look, we're adding color stops. So we actually got that far that it actually created some gradients. But then we're still white here. So let's take a look. We have other exceptions being thrown in API.js now on line 1, 2, 3, 4. So let's see what the heck that is. 1, 2, 3, 4. Could it be fill text? Guess that's also a Canvas API. Do we not support that? Oops, fill text. We do have fill text right here. So what was the exception text, by the way? Undefined is not a function evaluated from computed member expression. All right. I mean, like, I would assume that's that one. So who doesn't have fill text? Undefined is not a function evaluated from 3E06C1. So it's either this guy right here or this guy right here. What is 0x3? What's the relevance of this? Does not occur anywhere else. Cool. Fill text. I mean, I don't even know if this is a Canvas rendering context or what. I guess we can dump out whatever the heck this thing is here. So, let's see, console.log, this guy right here. Oh, maybe we can actually access it in the browser console. Let's try that first of all. So 0, let's just test something. Alert, hi. Do you even work? Yes, you do. Okay. 0x or underscore 0x, 3E 0x C1. Not defined. Cool. So it's like a local. Well, isn't that great? So let's see. Global this, is that a thing? Oh, did I just murder the JS engine? Oh, look at the CPU go. This could be that we have just a lot of things on the global object and it's just taking forever to generate markup for them, which would be really sad. Is that what's going on? Let's take a look. And I guess we can kill this thing. Okay, so what were you doing, web content? Painting. Painting what? Huh. That's a little bit weird. So it's just painting, I guess painting the output, probably. Jeez, why is that so extremely slow? Inline node paint. What did we do there? For each fragment. We're probably doing a whole bunch of expensive stuff here that we could do less of. Like all the self time is right here in this very function. Normalized border radius data. I don't know. Anyway, let's not get sidetracked with paint performance. I think I just have to be a bit more clever and avoid that thing for now. So let's just print this thing out. We have like console.warn, right? XXX. And then we will print the object that we wanted. So 0. This guy right here. Yeah. And maybe we'll also print out what is the result of this expression. I'm curious about that. And also, what is the result of looking up fill text in that thing? Okay, these are my main questions right now. So let's see if we can get some answers. Oh shoot, forgot to clear. Well, still time. Okay, what's going on here? Stroke text. Wait, what? Looking up that thing gives you stroke text instead of fill text. Oh, do we not have stroke text maybe? That would make sense. Oh, we don't have stroke text, so it's just finding stroke text and then we don't have stroke text. That makes sense. So let's just add a stub for stroke text. No big deal. Stroke text. Where's the IDL API? Right here. Fill text. You're gonna get a little brother named stroke text. And we don't know what unrestricted is in our IDL parser, so let's just remove those. But outside of that, it's actually identical in signature to fill text, so that makes things easy. We can just do this, just do that properly. And where's fill text? So I think, you know what, we can actually be a little sneaky here and implement fill text by just making a call stroke text, or rather implement stroke text by making a call fill text. I feel like, you know, it's not going to look right, but at least you'll get something. And we'll put a fix me here, you know, fix me, stroke and then text instead of filling it. Yeah. So we're just going to call fill text. Just like that. With a big fat fix me? Sure. All right. What happens if we run like that? Let's see. A little bit of a rebuild time there since I edited some header, and oftentimes in libweb when you edit one of the DOM headers or HTML headers, we have to rebuild all of the generated code because of exactly what you saw before in the wrapper generator, where it just spits out all of these include statements. This ends up creating a situation where like touching any header in libweb creates big heavy rebuild situation, which, you know, it's unfortunate. We could definitely improve this if we were to spend some time on just like untangling the dependencies and improving this thing so it doesn't spit out every possible header for every file. But that's not why we're here today. Today we are here to see if we can get some life in a particular page. Just some life. Any life would be a step forward. So, okay. Loady. Now we are failing somewhere else. API.js 1264. Cool. What's there? 1264. All right. 1264. The problem is undefined is not a function evaluated from this guy right here. Okay, so I think it's going to be this expression right here. Console warn. We can even just say missing right away. And this is the thing that we're trying to use it on. So let's just say on this guy right here. Okay, let's see how that goes if we do that. because I don't know what this thing is, and we don't know what the name. This is presumably the name of the API that it wants to invoke. Oh, there it is. Okay. Missing Bezier curve 2. Bezier curve. Well, we can certainly add that API to CRC2D. So let's do that. We don't have, we have quadratic curve 2, but not Bezier curve 2. We do have Bezier curve support in the SVG code, as I recall, don't we? Bezier. I feel like I worked on that at some point. Yeah. But once again, we don't have to actually implement these things if all that we're interested in just getting the DOM to load something. So we're just going to make a stub. And then we'll put it right under here. Although I wonder if this is, do we have an underlying path API? I don't remember. Mpath. Quadratic Bezier curve 2. Wait. Control point 1, 2, and P2. Oh, I guess I can actually pass those in. CP1X, CP1Y. I have to use these. And okay. Yeah, it's a cubic Bezier curve. To the point xy. So we actually can implement it by just calling through to our existing path API. Look at that. That's nice. Okay. I thought that was going to be a simple stub, but it turns out it got a little bit better than that. Not going to complain. Anyways, let's see what comes next. I wonder what is the criteria for like success today. I think criteria for success today is like seeing anything inserted into that empty DOM element. Then we can consider it progress. Or we can consider it success. We've already made progress. Okay, blah, blah, blah. And CPU spiking. Don't know what it's doing. What is it doing? Oh, we just don't know. Spinning. Maybe we should, let's just grab a profile, see what's actually going on. Could be interesting. So could be that it's doing something legit and we're just really slow at it, or it could be hung somewhere. Now our terminal is dead. Okay, I'm just gonna go ahead and I wanted to go ahead and kill that thing there. Oh, there we go. All right, and can we also kill the web content process? Doesn't want to die. That's not good. Okay, well, we have copied that profile to disk, so we can just reboot without the weirdly spinning web content process, and then opening the profiler should be a piece of cake. All right, so what on earth are you doing, my friend? regex. Ooh, well, we are very busy in regex. Cool. So we are doing regex op compare, and we have a lot of time in stuff like opcode compare size, regex, bytecode get opcode. Why are we spending so much time in these? That's a bit suspicious. Let's take a look at a top-down version here. If we look at, I guess, regex matcher, we can get just a good view into what it's actually doing. Just on a hunch, it feels like it's accessing a disjoint chunks data structure without flattening it first, which means that you have to walk all of the chunks instead of just doing random access into an array, basically. Yeah, this is a little bit concerning. Let's see, opcode compare execute. What does that do? Anyways, it's interesting that we are in regex. I have not seen this exact thing before, but I guess the first thing we can do is just print out what kind of regexes we're running here, just to get an idea of the complexity of the regex and the size of the input that we're matching, or the size of the haystack, I guess. So regex matcher is being called by regex prototype test. Sure, and that's in regex exec. Okie dokie. Regex built-in expect. Wait. Oh, this is the one I want. Yay. So where do we create the regex? Where do we run the thing? regex.match. Aha. And then we're going in a loop. Sure. Okay, I'm just gonna print it out when we run match right here. Is that in more places, actually? No, just here. Perfect. And then let's put that in some interesting color so that it sticks out a little bit. 35 maybe. And then we'll put our regular expression like this and our haystack like that. So regex pattern value, I think that's the regex pattern, and string.view, I guess, is I'll just do that to make sure that I can print out the thing, because we store UTF-16. JavaScript uses UTF-16, which is a very frustrating design decision, or design accident, I suppose. So I'm just going to convert the haystack to UTF-8 before printing it, just so that it's a bit more readable. So let's see what kind of regex we are actually running. Okay, let's just look for those purple. Oh no, what on earth? I'm guessing this is the haystack. What in the actual... oh no. It's matching it against base 64 encoded PNG. Why? Why are you running a regex against a base 64 encoded ping bitmap? That's really weird. Gotta love the web. All right. So what are we doing? We're just checking. Is this just validation that this is like only... We're checking for non-ASCII characters, I guess. Is that what this is? So code points above, hex 80 and above, right? So I guess a base 60, a data URL, a base 64 encoded data URL has only ASCII characters. So I guess they might be validating this thing, and then this is just slightly hilarious. So this is definitely going to need some thinking action. I'm going to ask Ali, probably, who is well versed in regex optimization. He already did a bunch of optimizations for our engine. So because I'm not exactly sure how to approach this particular problem, but we can work around it for now, I think, by just having us a little hack. So can we look for this thing here? Where is this thing? U0080. It only occurs once in this godforsaken file. Yeah, so here's the regex. And what are they doing here? So they're checking the regex against presumably this is like .test, I think we saw in the profile, right? And then they're passing in the arguments and also checking the unescape, blah, blah. So they're doing an assignment here. So I'm going to go ahead and cheese this a little bit. And I think we can just simply, I'm just going to comment this out and put a little marker here, XXXX. Hello, friends. Because we're going to do a little hack here where we just, you know, disable this little guy. Bloop. All right. Yeah. Let's see how that goes. And then we just don't run that regex. Yeah, there's probably some strat for optimizing that access. And it also looks like we need to flatten our regex bytecode. But even so, let's just bypass it for now. All right, so now we're running some other regexes, no big deal. And then we got finished here. And then what? Nothing. There's still nothing in the app-mount DOM element. Dang it. All right, all right. Okay, so I wonder what are we sending to this XHR here. I guess one thing we can do is we can open this up in Firefox. So make a private window, and can we get one of those thingies? And then we'll go to discord.gg, Serenity OS. And then we'll see if they load that thing. What was it called? CDN CGI. This guy right here. Okay, so what is that thing? Request. JSON. It's a JSON thing with a bunch of things in it. And the response? No response. All right. Well, that's not too much to go on. What's app mount? Is that some React thing or something like that? Vue.js. All right. Is that what they're using here? I don't even know. Okay, let's take a look at the resulting DOM if you do a load that works out. Then you get app mount, and it has a bunch of stuff inside of it. Sure. Some SVGs, and then the DOM. All right, but we don't get to that. That's fine. Were we doing anything with this? Okay, let's see what else was throwing. What was the last thing that was throwing here? Well, it's just, I guess this is just all the stuff that I was suspecting is feature detection and stuff like that. The last one that threw was on 4731, which is right here. Yeah, it just looks like more of that gunk. Maybe checking for reflect objects. And then here they're doing a bunch of checks against our user agent string. You can recognize it right here. It says Serenity OS in our user agent string. It also says not KHTML nor gecko, which is, I guess, novel. So the fact that they are regexing against our user agent string is a little bit of a hint that there may be some crap afoot or some dumb stuff. So let's just do a little test where we spoof our user agent. Let's just pretend to be Chrome Linux desktop, let's say. Just to check what happens if we do that, right? Because you never know. Did anything go differently? Doesn't really look like it. Of course, now we're pretending to be Chrome, as evidenced by our UA string here. They're checking for MSIE, stuff like that. Sure. Doing it a lot of times also. That's a little bit weird. Why are they testing it so many times? Or, oh, maybe that's because the regex is in a loop, actually. Or I don't know. So I guess we had this issue with the local storage on the main page. That was, I wonder if we're failing some essential script because of that. So let's take a look at, I guess we can just wget this URL and take a look at it. local storage. Yeah, so they're trying to get local storage. Dot get item. But it does look like they catch if something goes wrong. So I don't know. I don't know if everything else on the page sort of depends on the presence of local storage, but what if we would just do like a little bit of a hack? Nothing major, just a tiny bit of a hack where we would like add a local storage, pretend local storage object, right? So can we add it just anywhere? Script source. This gets pulled in pretty early, although wait, hold on. No, it's not early enough. We need to actually inject it earlier. So maybe we can just override this. So window.local storage is going to be this. Get item. And then, I don't know, we'll just do something like this. I don't even remember what local storage API looks like, actually. So this is the thing that they were calling get item. Returns what? A DOM string. The name of the key you want to retrieve the value of the key. If the key does not exist, null is returned. Okay, so let's just return null, you know? And then how do we override this file? It's a little bit trickier, I guess. We can do it here, I guess. Maybe in load request. If URL equal to actually this is the URL because this is just a shortened URL, so just to make sure that we actually get the right one. I hope that works. Let's try it. I just want to see what happens if local storage.get item returns null instead of throwing a type error because we don't have local storage. I'm just curious what happens. Okay, that didn't go so well. Res HTML Serenity OS. Oh, did I mess that up? Yes, missing a slash. That was goofy. Oh, dang it. The MIME type gets messed up. Let's do it this way. Yeah, for local files, we just guess the MIME type based on the file extension. So like if the file doesn't have an extension, we just assume it's text plain. Whereas if you call it .html, we will infer the MIME type text/HTML. Wait, I messed that up. How did I mess it up? How did I mess it up? That looks correct. Wait, what? What did I do wrong now? We're definitely inferring the MIME type wrong. Maybe it's not as simple as I was hoping. Text plain. Let's, we can just hack it somewhere, I guess. In, hello. All right, now suddenly C-line is very, very sad for some reason. Can't say this has ever happened before. I don't think I've ever seen C-line hang up. Oh, wait, did you finish? Oh, you did. Oh, thank you. Okay, so text plain in frame loader, I guess. So I'm just gonna go ahead and do a little bit of a hack here. I'm just oopsie whoopsie. Just treat text plain as parsable HTML. What could go wrong? And we'll see what happens. Okay, so now it looks like we loaded the page through the hack. We don't throw because of local storage, but we also don't actually see any difference. We didn't get anything in the DOM. Sure. We don't know why. And it could be so many things. This is a bit suspect, actually. Wait, what's going on here? Failed load of file. So we're failing to load a script. I guess maybe I messed something up here. File colon, oh, slash slash. Oh, wait, we were failing to load the script the whole time and I just didn't notice. Oh man, I'm such a dumbass. I guess the error was there also, but because it was green, I didn't even think about it. Okay, so I was missing a slash here, so we were not even loading this particular asset. Let's see what happens if we actually load that asset. Okay. Well, this is new. Look at all those regexes we're matching against the user agent string. Wow, it's really trying to figure out what kind of browser we are. Starting to think that maybe I shouldn't print out every regex that we run. But this is definitely progress. Okay, I'm gonna stop printing all their regexes. All right. So maybe if we're lucky, those little canvas additions actually created some progress for us that we can see now that we're loading all the scripts. Let's see. There are the canvas gradients, sure. And burning the CPU. Now we're throwing things again. Well, that's very interesting. All right, so we've stopped. And now it keeps throwing. So, could be something. It's always at the same place in this file. So let's take a look. At 153.767. Wait, what? Window.firebug.chrome is initialized? Well, I mean, it catches and then fails. So I guess it's just checking for Firebug. That's such a weird thing to do over and over. But all right. So I'm going to go ahead here and say that Firebug is never initialized, so hackety hack to get rid of that throw so that we can maybe see what else is going on, right? Hackety hack. So sometimes you kind of have to go in and get some exceptions and stuff like that out of the way, stuff that's generating unreasonable amounts of debug logging, because it's just impossible to see the important things when you have so much spam. And this technique of having a local copy of these minified programs, minified scripts, is really helpful. All right, so we finished and nothing. Okay, we're just steady stating. Nothing here, of course. All right, so what was the last thing then that went wrong? We're throwing here from document.hasFocus. Interesting. And then throwing undefined right here for some reason. Sure. Cannot find module enus. Okay. Add event listener, not an object of type function. Okay, so there's a bunch of stuff going on. What's the has focus? Where was that? That was the very last thing that we saw, right? Document.hasFocus. Okay, so that will throw. Where was it? 12, 22, 57. Right here. This will throw, which will then confuse things. So what if document.hasFocus didn't throw? Let's see, I guess it's just a Boolean hasFocus, presumably. MDN hasFocus, has locus, mocus, pocus. hasFocus, cool. All right, and then document.h hasFocus is not a thing yet, so let's just add it. Bool hasFocus. All right, so that's enough to start the build, and then we're gonna have to rebuild a bunch of things because of the header change, so we can edit the CPP file while we're building here. And I'm gonna go ahead and implement this as true for the time being, even though obviously return whether we actually have focus. Yeah. So it's just a hack to get something working. In the meantime, I guess we can do some commits. So let's get that canvas Bezier curve thing. We can definitely get that one in as a quick fix. No, yes, no, no, no. Split, yes, no. No. Did I manage to get only the curve stuff? Yes, I did. But let me also update the copyright date in this here file, since we're here anyway. libweb add canvas rendering context 2D dot Bezier curve 2. Was that the name of the API? Yes, it was. Okay, what went wrong? hasFocus was not implemented. Wait, what? I literally just implemented that. I guess it had built document.cpp before I actually saved the implementation. All right. And yeah, we'll see. I think a stubbing out document that has focus is totally fine for now. Where is the spec for this thing? Right here. Okay. Clickety click. Ooh, we got color. Oh. We got color and we're burning CPU and burning a little bit more CPU. Come on now. How far can we go? Look at that memory usage just crawling up there to uncomfortable levels. I wonder, are we running a regex again, perhaps? Oh, we can try to find out. But I have a hunch. Be nice if it would get to idle state so that we could actually inspect the DOM, because that's kind of a flaw of the JS engine as it exists at the moment, that if you are infinite looping in a regex or JavaScript or something like that, or just looping for a very long time, we can't actually inspect the page. So that can be a little bit frustrating. Let's see. So let's see. Okay, so we have our profile. This thing is not showing signs of stopping, so let's just do this. But yeah, we'll find out what's going on. But we all saw that we got some color there, so I'm suspect that we actually have something happening in the DOM. Okay, so we're not in a regex. We are in CSS selector matching. Fantastic. All right, so we are doing style invalidation due to attributes getting set. Okay, so the style invalidation checks are brutally inefficient if you have a lot of elements and a lot of style rules. So I'm gonna go ahead and just disable dynamic invalidation on attribute change to see if we can progress the load if we just ignore style invalidation here. Because basically style invalidation looks at an element before and after you change one of its attributes, and if the style of that element changes as a result of you changing the attribute, then we're supposed to sort of signal a re-style of the document and potentially a re-layout of the document. The problem is that we compute whether or not the style of the element has changed by running the entire CSS machinery on the element before the change and after the change, and then comparing the resulting style. And if you have JavaScript that's like goes and sets attributes on thousands of elements, we're just running the CSS machine over and over and over, and that's what we were seeing in that profile there. So now that I've disabled that, style can glitch out due to dynamic attribute assignment, but it will also complete way faster, as you can see. So what I want to see, did we get any DOM? Well, we got one little guy, but that is the success criteria for the day. I wanted to get something to load in this DOM, and my goodness, we got something loading in this DOM. Even if it's just a little loading placeholder or whatever, I'm still going to count it as success. So we have some commits to make here. So let's do that. let's see. Let's do the has focus stub. So just stub out has focus. Add a stub element. Add a document has focus stub. This always returns true for now. A proper implementation needs to check if the document is in an active window, etc. Active widget inside in the focused widget within an active window. Yes, that's what we need to check. But for now, we can just lie to web content and say that, yeah, you got focus. Don't worry about it. And then let's add the canvas gradient API. I mean, it's nothing fancy, but we can still add it so that we have that. Needs to be fleshed out, of course, but not right now. All the hacks, ignore all the hacks. Ignore hacks. We'll do stroke text separately. Yeah. Add stub, add bare bones canvas gradient object. Also add the canvas rendering context 2D APIs to go along with it. Note that it can't be used for anything yet. Yeah. This is very often how we have to go about sort of bringing up new websites, because it's not really feasible from like a mental health perspective almost to go and implement each one of these APIs completely as you go, because you would just never get anywhere and lose steam. At least from my perspective, I find it better to add these small, tiny bare bones stub implementations and get something that just comes up, and then we can go and fill in the implementation of these things later on as we go, to then increase the fidelity of the websites. But for the initial bring up, I find it better to just do the bare minimum to get something showing up at all. Make add fake, or like forward canvas rendering context stroke text to fill text for now. Or let's see, this is a temporary hack. This is a hack until we get an actual text stroking implementation. All right. Did I have more reasonable hacks to commit? No, everything else was just hackery gunk. So yeah, and then there's all kinds of errors. Even when I move the mouse around, we get errors. So there's more stuff to investigate in the future, but for now, I achieved what I wanted to achieve. Well, we'll be working more on this, that's for sure. Anyways, so this was a little bit of an unusual video, but I hope that you saw something interesting here, and thank you very much for checking it out. I am glad to have made a little progress towards running Discord in the browser. A lot more of that to come for sure. Thank you very much, and see you next time. Bye.